Today we are going to discuss what is mean by an LR parser. Okay. So in the parser we are having two types of parser. First one is top down parser and second one is bottom up parser. So first we will see the bottom up parser. Okay. In the bottom up parser we are having two types. First one is a LR parser and we have another type also, that is operator precedence. And second type is LR parser. So today we are going to discuss what is mean by LR parser. Okay. So LR parser is an bottom up parsing and it is used to parse the large scale of grammars. Means different type of grammars are being parsed in the LR parser. Okay. In the LR parser, the first L represents the left to right scanning of an input string. Okay. That is nothing but we are going to scan the input from left to the right position. Okay. So first L represents the left to right scanning of input. Second, R represents the construction of an rightmost derivation in the reverse format. Okay. So rightmost derivation will be performed, not the leftmost. It is going to perform the rightmost derivation. So it will scan the input from left to right and it will do the rightmost derivation in the LR parser. So we will see the structure of LR parser. So look at the diagram here. This is the structure of complete LR parser. First we will take the input buffer. So input buffer is stored here and this is an stack where our input is stored. So first stack, the starting symbol will be $. Next, coming to the LR parser. In the LR parser we are going to include the parser algorithm, and in the LR parser we are going to perform the parsing table. In this parsing table we are having two conditions, that is first one is action and second one is go to position. So what is the actions that are going to perform in the states, that we are going to list here, and what is the condition from which state to which state we are moving. Those transformations will be seen in the go to operations. Here in the actions we are going to see the terminal symbols, and in the go to we are going to see the non-terminals. Okay. So in the LR parser we are going to construct the parsing table, and finally after construction of parsing table we will get the result as an output. Okay. So this is the structure of LR parser. In the LR parser we are having different types of LR parsers. So types. In types, the first one is LR0, second one is SLR, third one is CLR, and fourth one is LALR. So this one is a simple, this is an LR is an normal LR parser. So it is a production. We are going to include the LR0 items for LR0 and SLR. LR0 items we are going to include, and here in the CLR and LALR we are going to include the LR1 items. So what is mean by the LR0 items means, for the productions we are going to include the dot at the right hand side of the production. In the right hand side of the production we will include the dot symbol, that is nothing but the LR0 items. So in LR0 and SLR we are including the LR0 items. So coming to the SLR and LALR we are going to include the LR1 items, means LR1 includes LR0 items plus we are going to add the look ahead symbol also. Okay, so look ahead will be additional for the CLR and LALR. So in the bottom up parser, first we will continue with the first parser, that is LR0 parser. Okay. So to do the LR0 parser, we are having the steps that are to be involved while we are performing the parsing. Okay. I'll write the steps here. The first one is, for a given input, write CFG, that is context free grammar. For any input string, first write the context free grammar. Next, check for ambiguity. If any ambiguity is there, you have to check the ambiguity for the given input. Next one is add argument prediction. I'll tell you what is mean by argument prediction. Next, coming to this next point, create canonical collection of LR0 items. I have already told you have to include the LR0 items for LR0 parser as well as SLR also. Next one is draw the LR0 parsing table. Next, finally, you have to draw the transition diagram. Okay. So first point, you have to check the given input and write the context free grammar for that given input. Check for the ambiguity. If any ambiguity is there, you have to check for the ambiguity, and you have to add the augmented predictions also. Next, after adding the augmented prediction, add the canonical collection of LR0 items. Means you have to include the dot prediction in the right hand side of the prediction. Okay, you have to include the dot prediction in the right hand side. Next, after including the canonical collection of LR0 items, you have to parse the table. Means after parsing the LR0 items, you have to include those in the parsing table. Next, you have to draw the transition diagram for that particular parsing table. Okay, we'll see with a small example LR0 parser. So look at here, this is an example. We are having two prediction, that is S tends to AA and A tends to small a capital A slash B. These are the predictions. So for this prediction, you have to add the first, you have to add the augmented prediction. What is augmented prediction? You have to write, take the starting symbol, that is S dash tends to dot S. This is an augmented prediction. Prediction. So this prediction will be helpful to identify when to parse the parser and when to accept that prediction also. It will give the idea. I'll write here augmented prediction helps us to identify when to stop parser, and also it will give the information when to accept the prediction also. Okay, so that is why we are adding the augmented prediction with our grammar. So first S dash tends to dot S, first augmented prediction. Next, take the next prediction, that is S tends to add the dot here. We are doing the canonical collection of LR0 items. What is the canonical collection of LR0 items? You have to include the dot symbol at the right hand side. Okay, so S tends to AA. Next, take the next prediction for the A tends to dot A capital A dot B. Okay, So all the small letters are known as terminal symbols and all the capital letters are called as non-terminals. Okay, I'm repeating once again, all the small letters, that is lowercase letters as well as symbols, is termed as terminals, and all the uppercase letters are termed as non-terminals. Okay, now these are the productions. So for this productions you have to do the canonical collection of 0 items. So first you mark it as this state as I0. Okay, so first mark this state as I0. From this you have to do each and every production. First take the S production, that is S tends to dot S. This is an augmented production. Yes. So dot should be shifted at the last of the right hand side production. So this dot should be shifted in the right hand side for every production. Okay. So S dash tends to S dot here. Means this dot symbol we have shifted to the rightmost derivation. Okay. By taking the non-terminal. So mark this state as another state, that is I1. We have already given the I0, so give the state number as I1. Take the next production, that is A. Next production S tends to dot AA. So take the first symbol of A, then S tends to A dot A. Okay. So after the dot we are having the non-terminal. If in case we are getting the non-terminal after dot production, you have to include this A productions also. Okay. So after dot we have A non-terminal. So you have to include the A productions also. What is the A production? A tends to dot A, capital A, or dot B. Okay. You have to add this A production also. Why? Because after dot, after shifting the dot one position, we are having the non-terminal. So for that non-terminal we are writing the productions. Okay. So next take the small a, that is terminal. So A tends to A dot A, means only we are taking A tends to dot small a, capital A. I have shifted the dot symbol to one position. So after dot we are having the non-terminal. So after dot, if you have the non-terminal, what you have to do? You have to include the A productions also. So A tends to dot A, capital A, dot B. Okay. So all the productions you have to include. So this next symbol also you can write down also, no problem. If you want you can write here also. Okay. Everything is same. So we have completed up to here. We have A tends to dot B also. So take the B production B. A tends to B dot. We have shifted the dot from here to here. Okay. So this is already I1 state. Give the numbering as I2. Next this state as I3 and this state as I4. Okay. So take the I1 state. So I1 is the final state where we have already shifted the dot symbol to the rightmost derivation. So no need to change this I1 state. Come to the I2 state. In the I2 state we are having dot in the middle. So you have to change this. So A, S tends to A dot. Okay, we have shifted the dot symbol for the rightmost. Okay, this is one state. Next take A state. Next production. A tends to take this terminal. Then A tends to A dot A. Okay, we have shifted the one position. Next, take the A tends to dot B. So dot B we are having already in the I4 state. So you can directly, no need to write the another state, you can directly mark like this, B state. Okay. So we have completed all the states in I2. Then coming to the I3 state. So what happens? Take the capital A. So this symbol A tends to A, capital A dot. We have shifted the dot symbol here. Okay. So see here, in this state you are already having this state in the I3 state, this A state. So you can directly give A state to here. No need to write this state again. Okay. So you can directly mark like this also, no problem. Okay. Next you are having the B state. For the B state you can give like this B. Okay. Next for this state we have this one also. You can keep the self loop, that is A. Why? Because if we transfer this dot symbol to here, we'll get again A dot A. So this is already in the same state. So we have to keep the self loop. Okay. So we got the sixth state here. Mark this state as I5 and this state as I6. Okay. So don't write these states. You can directly give it to the I3. Why? Because these two are same. Okay, this state and this state is same. No need to give the double states. So here in LR0 we got the 6 states. So for this 6 states you have to draw the parsing table. Okay, I'll draw the parsing table here. So to draw the parsing table, first write states. Next action. We are having two columns. First one is actions. Next one is go to. In place of states we are having 6 states. We got 6 states. You have to write 6 states. So write the 6 states. How many states you are getting in the diagram? Write the 6 states. Next, in the action you have to take the terminals. So how many terminals are there in our production? See the productions once. So how many terminals we are having? A, B. We have 2 productions and we have to include the dollar symbol also. Okay. So in the action you have to write A, B and dollar. Okay. These are the terminals. In the actions you have to write only the terminal symbols. In the go to you have to write the non-terminals. So how many non-terminals are there? Check the productions once again. What are the non-terminals? S and A. These are the 2 non-terminals. You have to write the 2 non-terminals here. S as well as A. Okay. So this is the table you have to write for the parsing table. Okay. First you have to include the action and here non-terminals. In the action you have to write the terminals and in the go to you have to write the non-terminals. And in this you have to include the states, 6 states. Okay. So you have to check from the first, from I0 to A. And from I0 we are moving the A symbol. From I0, this is the I0, right? From I0 check the A where it is moving. From I0 to move A, it is going to I3. Okay. So this I3 you should not write directly I3. You have to write the shift operation here. Means you have to write S3. In the actions everywhere you have to write only the S. S is nothing but shift operation. Okay. In the go to you have to name directly numbers. No need to write the shift operations in the go to, but in the actions you have to write the shift operations. Okay. So next you check the I0 to B. From I0 B is moving to I4. So see here I4. Means you have to write the S4. Okay. Next, from I0 to dollar we are not having anything. See here I0 to dollar we are not having anything. Next, check from I0 to S. It is moving to number 1. First state. So you have to write 1 here. Yes, number 1. Check from I0 to A where it is going. I0 to A, it is moving to the I2 state. So mark it as 2. Okay. Next, being an A, first I1 state as a final state, we are not having any predictions here. Okay. Why? Because I1 state is already a final state. Okay. So in the I1 is in the first state, in the place of dollar you have to write the accept. Why? Because this is an augmented prediction. In the place of dollar, S dash tends to S. It is an augmented prediction. In the place of I1, dollar will be accepted. So you have to write in the place of I1 dollar symbol, we have to accept the string. Okay. Next, coming to the next state from I2 to A. Check the I2 prediction from I2 where A is going. I2 to A, it is moving to I3. See here, I3. So you have to write S3. Okay. Next from I3, from next second state to B. I2 to B, it is moving to, from here I2 to B, it is moving to the I4. So write a S4. So from I2 we are going to I2, B, it is going to I4 state. So I have written S4. Next check I2 dollar. So now for dollar there will be no predictions. So check I2 to S. Check the prediction from I2 where it is moving. S is not moving, just we are having only A. From I2, A is moving to I5. So then what you have to write? From I2, A is moving to 5th, that is 5. It is moving to I5. So here in the go to states you have to write only the numbers. You should not write I5. Okay. Next check the third state from I3. From I3 where the A is going. Check here. See the diagram. From I3, A is, small a is going to self loop. Self loop we are having. So what you have to write? You have to write S3 only. Next you have to check I3 to B. So I3 to B, it is going to I4 state. Okay, it is going to I4. So you have to write here S4. Okay. Next from I4 to A, where it is going. I4 to A, it is a final state. We are not having any predictions. So what you have to do means, in this case you have to perform the reduce operation. Why? Because this I4 is an final state. It is not going to give any state. So what we have to do means, so take the predictions here. What is our predictions? I am writing here. S tends to S, S tends to dot A, S tends to dot A, and S tends to dot B. So this is the first prediction, this is the second prediction, this is the third prediction. Okay, so these are our predictions, 3 predictions. I am numbering it as first prediction as first one, second prediction as second one, and third prediction as third one. So here check out, we are checking for the reduce operation in the I4. Why? Because here we can't shift the position. Why? Because this is a final state. So at this situation we have to reduce the operation, means we have to reduce the predictions. So see here in I4, A tends to B. So what is there in the prediction? A tends to B is numbered as 3. So reduce R3. Reduce R3. So you have to write R3 in I4A position R3 and I4B position R3 and I4 dollar position also R3. That means in LR0 total complete row you have to write the reduce operation with the same numbering. Okay, complete row you have to write in the action column. complete row you have to write. So take the fifth state from I5 to A. Check out the fifth state. Fifth state is also an final state. So you have to perform for this also. S tends to A is numbered as which operation? S tends to A is an first production. So R1, first production means R1. This R1 you have to write complete row. Okay. So in the complete row R1 you have to write here. Okay, this is in the complete row you have to write R1 production means reducing first operation. Take the I6. So I6 is also in final state. So you have to check for this production. A tends to A, small a and capital A. You have to check which production number is. So this is the second production, right? So second production means what we have to write? R2. You have to write R2. So this R2 you have to write in the complete row. So see here I am writing R2, R2, R2. Okay. So see here in I3 A position we are going to sixth state. See here in I3 capital A positions means non-terminal we are going to I6 state. Okay, I forgot to write here. So write here sixth state. Okay, this is an table to construct the parsing table. So this is a parsing table. Main you have to remember here is in LR0. So reduce operations you are going to write for the complete row. Okay. Major difference between all the LR parsers is in the LR0 you have to write the reduce operation for complete row. Okay. You are seeing here for complete row we are writing same reduce operations. Okay. So this is about LR0 parsing table. So now we will parse the input string. Okay. So given input string is AABB. Okay. This is an input string. You have to parse this input string in LR0. So to parse, first you have to write steps, next parsing, stack, next input, next action. Okay. So 4 steps. Parsing, stack, input and actions. You have to parse the input string AABB. So in the first step take stack 0. 0 is nothing but first initial state I0. Okay, initial state I0. Next take the input string AABB $. Okay, so first you have to check in the table I0 to A. Means I0 to A position where it is moving. Okay. So see here I0 to A where it is going to S3. It is going to S3 means shift 3. Okay. You have to write shift A3. Okay. So this A3 you have to shift to here. In the second step $0 A3. Next this A has been already shifted here. So remove this A. Write ABB $. Okay. Next. So check now I3 state to A. I3 state to A where it is going. So see here I3 state to A. I3 state to A where it is going S3 means shift 3. So I am writing here shift A3. So this A3 should be shifted again here. So write the step 3 $0 A3 and this A3 should be shifted here. Next this one is completed. So take BB $. So now check for I3 to B. I3 to B. So I3 state to B where it is doing S4. Okay. S4 means you have to write B4. So what we have to write? Shift B4. Okay, so this B4 you have to shift here. $0 A3 A3 B4 BB dollar. Sorry, single B. This B already shifted, no? So single B dollar. Now you have to check for I4 and B. So see here, I4 to B. Where it is going? I4 to B, R3 means reduce R3. So you have to write reduce R3. What is the production of R3? A tends to B. A tends to B is the R3 operation. Means in the place of B you have to substitute A. Okay. So in this production, in the place of B you have to substitute the A. So step 5. $0 A3 A3. In place of small b I am substituting capital A B dollar. So now see here, we don't have any other state here, means we don't have any number to find the state with B. So what we have to check means in I3 place where the A is going. Okay, in I3 place, check here. In I3 place where the A capital is going to 6, right? So 6 you have to write here. You have to check for I3 to A, capital A, where it is going. So 6 here. So now you can check that for I6 to B where it is moving. So I6 to B means I6 to B where it is going to R2 means reduce R2. Okay, reduce R2. What is the operation of R2? A tends to small a, capital A. So in the place of capital A means small a and capital A means this small a and capital A you have to substitute the capital A. Okay. So write here 6th step $0 A3. In place of A3 capital and a small letter you have to substitute capital A B dollar. So same as we do in the last, we don't have any number state here. So what we have to check in I3 position where the A is going, same state. So you have to write 6 here. Okay. So if you want you can check here also. I3 position capital A where it is going to the 6th position. So I am writing here 6. Okay. Now check for I6 to B. I6 to B where it is going, reduce again R2. Reduce R2. Again I will show you I6 to B. I6 to B where it is going R2. So what is the operation of R2? Same. A tends to small a, capital A. Okay. So in the place of small a and capital A you have to substitute the capital A. So write the 7th step. $0 in place of this complete you have to substitute A B dollar. Next check, we don't have any symbols here. We don't have any state here. So what we have to do in I0 position where the A is going. In I0 position, I0 to capital A how much value? 2. Go to 2. So write the 2 here. Now you have to check I2 to B where it is going. So check and see the table. I2 to B where it is going, shift S4 means right here shift B4. Okay, this B4 should be shifted here. Write the 8th step $0 A to B4. So this B will be already shifted here, no need to write the B. So dollar is remaining at the last. So I4 to dollar, check. I4 to dollar where it is going. So I4 to dollar where it is going, R3 means reduce R3. Reduce R3. What is the operation of R3? A tends to B. In place of small b you have to write the capital B. So in the 9th position $0 A to, in place of small b I am writing capital A, dollar. Okay, so now next we don't have any symbols here, we don't have any states here. Now you have to check for I2 state to where the A is going, go to statement. I2 to where the A is going, to the 5 number. Okay, write a 5 number here. Okay, now check for I5 to dollar where it is going. So see the table, from I5 dollar where it is going to R1. Okay, so reduce R1. So what is the prediction for the R1? S tends to AA, means in place of A you have to substitute the S. So here A is there, here A is there. So remaining these numbers leave, nothing will problem. So in place of this AA you have to substitute the S prediction. So step 10, $0, capital A, dollar. Okay, so remove these numbers, no problem, but starting should be left like that only. So now you have to check for, we don't have any other state to check for the dollar. So what we have to do, from I0 where the go to statement A is going, from I0 to A, what is the statement? 2. So you have to write here 2. From I2 to dollar where it is going, just 1 minute, from I0 to A. So see here ma, yes, A is A we are substituting, in the place of A we have to substitute yes. Here it will be yes, not A. Okay, okay, AA places, in place of A and A we are reducing the operation with S. So write here S. So now check I0 to yes. I0 to S where it is going, I0 to S it is going to 1. Okay, write here 1. Okay, now I0 state to dollar where it is going. So check for I1 state to dollar where it is going, we have to accept the string. So write here accept. Okay, so this is the input parsing. This is the input parsing in the LR0. Okay, thank you.